Hello viewer, welcome back to Artistry. My name is Ongweso and I'm going to present a topic in electrical engineering under DC circuits. Today we are going to look at Kirchhoff's theorem. Kirchhoff's theorem. And under Kirchhoff's theorem we have what we call Kirchhoff's voltage law. So before we proceed with this, let us remind ourselves about our previous class. Last class we discussed about DC parallel circuit. So we managed to interlink the Ohm's law and Kirchhoff's current law, and we managed to come up with some formulas. We derived that in a parallel circuit of any kind of resistance, you can get a total by using this formula. So you can use this formula to get the total resistance in a circuit in any parallel using this formula. Or we derived another special case for two resistors in a parallel where we came up with this. So if you have only two resistors which are being connected in parallel, we have this. At the same time, we discussed that the current in the circuit, according to Kirchhoff's, the current entering a junction is equal to the current leaving the junction. At the same time, we discussed about the voltage. We saw that the voltage at the different parts of the circuit is the same as the source voltage. So using those principles, let us add now another theorem we call Kirchhoff's voltage law. Kirchhoff's voltage law, it states that in a closed circuit, the sum of all voltage drops. The sum of all voltage drops is the same as the source EMF or supply. So the voltage drop in any closed circuit is equal to the source voltage or the supply voltage. For example, if we have a circuit like this, this is R1, this is R2, and here we have the current I, this is the voltage V. This shows that the voltage drop across this resistor, if we put V1 and we put another voltmeter here, V2, so the voltage drop in this circuit is the same as this. That shows that the voltage E from the source is V V should be equal to I times R1. I times R1 plus I times R2. The current times the resistor, you get a voltage drop in this resistor. And the current I times this, you get a voltage drop in this. If you take the sum of these two resistors, or the voltage drops in these two resistors, you will find that the total voltage is equivalent to the supply source. So this is the same as to say that V equals to V1 plus V2, because if you take this, it will give you V1 of voltmeter V1, and this will give you V2 of voltmeter V2. But let us now compare a circuit which is somehow complex, apart from the ones we have discussed. If you have a circuit like this, this is R1, R2, and this is R3. And let us assume that in the first loop, this one, we can call this loop 1. Because if you consider only this, it is a closed loop. It is complete. So we consider this, and let us call this I1. And let us call this circuit loop 2, because it's also complete. And let the current across this be I2. So according to Kirchhoff's, is that in any closed loop like this, the total voltage drop here is the same as the voltage from the source. Like now, the second loop, we don't have a source of EMF. So that means that the voltage drop in this and this must be equal to 0, because there is no source of EMF. Now let us consider loop 1. So in loop 1, we have V, the source. So V is equivalent to the voltage drop in I1 R1 plus, if I1 is coming this way, and we say this I1, so it will be I1 R2. So if the values of these figures were given, so in the first loop we have this, and now we can call this equation 1. Loop 2, it is also a complete loop, but it does not contain any source of EMF. So we say V is 0 is equivalent to, let us start from this junction, going this way. So R3 is being subjected to I2. So we have I2, R3. When we come to this branch, the loop, as we are moving, we are going against the flow of current of I1. That means if you are going against the current, so we say we use a minus sign to show that we are going against I1. And therefore, we have I1, I2, this becomes equation 2. This is how we relate with Kirchhoff's voltage law. You consider a complete loop. Let us take a practical example with figures so that we can calculate these values. For example, this loop has a source of EMF. And now R1 is 5 ohm, R2 is 10 ohm, and this is 20 ohm. And the voltage here is 20 volts. They take I1 to be 2 amperes and the I2 to be 10 amperes. Or else we say the currents are not known, so we are finding the value of currents. So the question is find the current I1 and I2 in the network above. If you can consider loop 1, it has a source of EMF V. So V is given by the voltage drop in this circuit, I1 R1 plus I1 R2, I1 R2. So if V is given, R1 and R2 are given. So V, if you substitute the values, V is 20, I1 is not known, R1 is 5, whereas I2 is 10. So we have this is 5 I1 plus 10 I2 equals to 20. That implies that I1 and I1 are common. So we have 15 I1 equals to 20. Therefore, I1 is 20 divided by 15. 20 divided by 15. So we get 1.33 amperes. That is when we consider loop 1. Let us consider loop 2. In loop 2, let us start from this corner here. We go this way. So we have I2, R3. We come through the source, but now we are going against the flow of I1. So we have minus I1 R2. The source of EMF in this side is let's take 20. Take a different value, 30 volts. So if you say it equals to 30 volts. Now I2 is not known, but R2 is known. We have 20 I2 minus 10 I1 equals to 30. But the value of I1 is known. I1 is known. So it is 1.33. So we have 20 I2 minus 10 times 1.33 equals to 30. This is 20 I2 minus 13.3 equals to 30. So let us take this to the other side. 20 I2 equals to 30 plus 13.3. 20 I2 equals to 43.3 when you sum this total. That implies that I2 equals to 4.33 divided by 20. If you divide by 20 both sides, so you get 2.165 amperes. So that is the answer. That's how we can relate these two. So that means if you have a circuit with so many sources of EMFs, you can use this Kirchhoff's voltage law so that you can analyze the system, you can know the current in that circuit, you can know the circuit which is having maybe a high resistance, such that you can adjust to have more efficient and even to improve the efficiency of the system. Coming to the end of the lesson, we can summarize what we have learned today. Today we have covered about Kirchhoff's theorem, and we have stated Kirchhoff's voltage law. And the Kirchhoff's voltage law states that in a closed circuit or in a closed loop, the voltage drops in that circuit is equivalent to the source EMF or to the supply. So if you have the resistors in a circuit, the voltage drops in that circuit is equivalent to the supply voltage from the source. That's the end of the lesson. I have been your presenter, Dennis Ongweso. Keep tuned to Elimu TV.